Cult of the Lamb is an adorable indie game where you build up a cult full of cute furry creatures, fight monsters and literal gods, and in that game, there's a mini-game called Knucklebones. Now, despite sharing the same name as an ancient game where actual knucklebones are used, this game is actually dice-based and is coined as a game of risk and reward. And you know what? It's actually really fun to play, so I decided to bring the game into the real world with my fully 3D printed version. This design has some neat print-in-place geometry, and it prints in just a couple of hours, and let me tell you, with Christmas coming up, you'll want to be playing this a lot more than Monopoly. Let's get started. What I find interesting is that the creator of Cult of the Lamb said that they came up with the idea of the Knucklebones minigame themselves. They sort of invented it, which is really interesting because it's a dice-based game and almost every dice-based game has already been invented. There might be stuff that's similar to it, but I really enjoy the simplicity of Knucklebones in Cult of the Lamb because it's very much chance-based, but there is a little bit of skill involved. And the way it works is that you could be almost winning, but then have all of your wins stripped away like that when your opponent gets a lucky roll. This video is going to be split up into several sections, starting with the design phase, the printing phase and assembly, and then how to play this game. But if you want to just skip to the chase and get the 3D printable model for free, well, it's linked in the description. So to start, let's look at some footage of Knucklebones from Cult of the Lambs. To play, you take turns rolling one dice each, and you place it into one of your 9 slots. And if you manage to put 2 or even 3 of the same number in the same column, well then those numbers are added and then multiplied by the number of dice in that column, which means you can get some pretty big scores indeed. But here's where the risk comes in. If your opponent rolls that same number, they can put it into their column opposite yours and make you have to remove all of the die in that column of yours that have the same number. So you could have 3 6s, and they could just put a single 6 and wipe out that gigantic score instantly. It's just why this game can go from ecstatic wins to miserable losses in an instant, and why it's a fantastic game to bring around this Christmas. Now, I could just design the board all in one plate, but I want this to be travel sized. So I had this idea of having the board fold in half because, well, it's essentially mirrored on both sides, and then they could just go into a little box. I've played a lot of travel games that work like this, like Travel Chess, Travel Checkers, where the board actually folds in half and actually hides the pieces within it, and it actually works very well, so I thought I'd have a crack at doing that here. So here we have one half of the board, which is created with 2 extrusions. I have this top extrusion that will hold the dice in place and gives us a little area to roll them as well. And then the bottom plate here, which is only 1.6 millimeters thick, gives us a bottom surface. The idea here is I'm going to have 2 of these pieces, which effectively form a board like this, but I want them to fold up into themselves into a little sleeve for transport. And with the dice that it uses, I want them to be stored in the little rolling area when they're not in use. Because this is travel sized, I've designed it to take 10mm sized dice, which are quite small, and I've actually got my hands on some really cool bone dice. They're not exactly balanced, but I'll put some links in the description below where you can get some really cheap, nice looking 10mm dice. And you need about 17 for this game, because the most you'll ever need is some player will end up with 9 when the game ends, and one other player will end up with 8. So you need 17 dice, and they'll fit in the little storage area, no problem. And I've got a nice big clearance, because again, we don't need to worry about these dice being a very tight, snug fit. The holes for the dice to sit in are 12, which means you can reach in and grab them no problem, and then they're not going to have any issues with them getting stuck or your print having clearance and tolerance problems. There's various ways you could join the 2 pieces together. You could just use magnets, you could clip them together, you could just not bother, but I want to make this print in place with a print in place hinge because I'm just extra like that. So let me show you the geometry that I created to make these print in place hinges work. I started by cutting away material to leave behind little axles in each corner of the board. You can see here that this axle is only 3mm in diameter, and it only cuts away 5mm of material. So it's going to be quite small. I wouldn't go any smaller because this has to be printable on FDM 3D printers, but it's actually already, due to the size of things, already taking up a fair bit of real estate. So I did have to shift around a few things and make sure that there was enough room on the board for this extra print in place geometry. But you can see I've actually done some clever stuff with the extrude feature here. I've actually got the sketch on the edge of the model, but then I've offset that sketch 3mm into the model, and then I've done a distance of 5mm cutting it like that. And it's cutting away the actual material that exists, leaving behind the cylinder. So I'm not cutting away material then adding in an axle, I'm cutting away material to just leave behind an axle like that. I've also got a circular detail here, which means that when I add my hinge detail, it should allow clearance for that hinge to move up and down, and then let the board fold in on itself. I then patterned those hinge details to add 3 per side of the board, and then the most important thing to consider is how does this fold up on itself, and will there be any collisions? So if I look at the side of this board here, I want it to fold from this bottom part here into itself, well, it's going to collide and it's not going to clear. So if I do want to fold this in on itself using these hinges, well, then these top parts are going to collide. So the next step was to essentially remove them, add clearance there, so when this folds in on itself, those corners don't collide with each other. Don't worry, this will all make more sense when I start to rotate the parts and you can see how they move in and out. And I was going back and forth between parts of the timeline to get this right. I didn't just know off the top of my head where to remove material to make clearances. From here, I mirrored the body and this is what it looks like. So what we need to now do is add those hinges in that will be printed in place so these parts can independently rotate around and close flat, but then open flat as well. They can't hinge directly into each other because they wouldn't be able to lie flat or close completely flat. I wanted this model to store snugly in the box and then also lie flat on the table, which is why I went with the 2-axle design versus a single hinge with the parts interlocking. With that in mind, the hinge detail is very, very simple. It's just essentially copying those axles. So I just did a project sketch there, and then it's a slot. So it's just a circle with 2 additional lines joining them together. And then from there, this hinge detail was extruded using the 2-object extent, which lets me terminate it at the end of that hinge slot. And it's a new body, which is very important. Otherwise, we'd be joining these parts together permanently, and that's not what we want. So here we have a close-up side view of one of those hinge details with the 2 halves of the playing field. And what I want to show you now is a few tricks you can do to make your models print better, especially when it comes to printed place models without support material. So this slot here, this circle, as it comes around to the print surface, that's a huge overhang initially. It's like almost completely over thin air. And that's where you actually start to get failing. You might have the print start to warp up and collide on the nozzle and fail. So what I actually do here is I add in a little step. So this step essentially is just a 45-degree angle up to the tangent of that circle, that arc. And a 45-degree overhang is no problem for an FDM 3D printer. So as the model's formed, it's fine. And then the arc takes over and the print continues. Also, I've done the same here for the bore of our print in place hinge. Because again, coming to the top of that circle, it's a bore that's forming over thin air, it'll actually start to fail. And I've noticed in some slices now, they make a really thick bridge to cut off the top of bores. Like it'll actually just bridge between like these 2 points, which means that the holes succeed better, but the geometry is ruined. And that means it won't actually have a print in place effect. So I've done the same thing with that angle there. It's actually a little bit steeper than 45. I believe it's 60. But look here, yes, 60 degrees. Again, it's so small, 60 was much better than what it was before. And that gives you just a little bit more clearance on that printed place area. And then you end up with something like this. Now the parts are currently directly touching with 0 clearance between surfaces. I add the printing clearances right at the end because I can change them at any time to make the parts fit looser or tighter depending on how I find they actually print. On a similar vein to adding the 45-degree support for the hinge, you see I've actually added a 45-degree chamfer on this side of the model. Now this is actually removing contact surface area for that first layer, but it's actually what it's doing is creating a larger gap between these 2 parts. Because with printed place models, even with a perfect first layer, you'll get a little bit of squish, and you want to make sure that that squish doesn't weld your printed place models together. So with my clearance gauge, for example, that is the #1 reason for failure. Same with the clearance castle. People have that first layer too close, and all the printed place geometry welds for 1 or 2 layers, and they don't separate. Because the distance between the part and the hinge on the side is also very, very close, I add a chamfer to the side that has the most contact area, so I don't end up losing parts because they just break free. And what you end up with is as much gap as possible, you can see here, between the printed place parts, even though it looks a bit funky, to make sure they will separate with no problem. Let's talk clearances. Print in place models need clearances to succeed, and up to this point, I've shown you with all the parts touching each other. So how do I add clearances? Well, I use the push-pull feature in Fusion, and then what I'll do is I'll go around, find the areas that I want to modify, and I'll add my clearances. So what I've done here is I've clicked, for example, that face. I've clicked the bore like that. And then it's moving these surfaces a set amount. Now I've got my clearances set at 0.5 millimeters, which means it's moving the surfaces 0.5 from the other surfaces, which is more than you probably need. A lot of printers can manage 0.3 or even 0.2 millimeter clearances with no problem. And when you want parts to be as constrained as possible, you might go to those tighter clearances. But this is a game board. The only purpose of this hinge is to make sure that these parts are constrained together when they're in the case and then laid out flat. I don't care about this gap in the middle being wider than what it says in CAD because of the clearances being quite large. It actually doesn't bother me. Printability is what is most important, which is why I've set my clearances here to 0.5, and you can see just how much of a difference that makes to those surfaces. Adding clearances like this is tedious. It's a little bit annoying. You have to make sure you click all the surfaces, go around again and again. It can be a bit buggy, but I just find when I'm modeling stuff like this, where I'm not bothering to do component level modeling, it works fine. And I can always go back and change this number or change which surfaces I want to offset as I see fit. So at this stage, I've designed the board how it would be open and printed, but I need to make sure it can actually fold, and also I need to design the case around it. The proper way to do this would be to use components, to separate these parts into components and use mates, but because of all the clearances I've added, it's a little bit tricky to make sure the parts are exactly where you want them, and I'm not trying to show full movement range of this design. I just want to fold it 90 degrees so I can design my case around it and make sure it fits. So to do that, the easiest way is to use the move and copy command. Using the command can be a little bit finicky, but what you want to do is select move object, and then with selection, it'll actually work quite a lot like how the joints work when you're working with components, but we want to select that hinge point. So I'm going to turn off everything else except that hinge point, and I can select any one of them. Let's just select that one. And then I'm going to rotate it 90 degrees up. Like that. And then you just do the same with the other side. And then just like that, we have now closed it. And it's all parametric. You can go back in time and change things, and then go back and close it back up. I just find it's a much easier way to do it without things exploding like with joints they often can. Now with the model in the closed state, it's a great time to check for any interferences. Is there any part of the model that is colliding with itself? Because you can actually see as you close it using the move command, you can actually see how it rotates into place like that. Now it comes really close down the bottom to actually colliding. But because again, I've got that 0.5 clearance, I don't think that's an issue, and it's gonna lie flat like that when fully closed, which means it'll sit snugly into our box. And you can go back and forth as much as you like to fine tune this as much as you want. But then there's also a really handy inspect option to show you if there's any collisions within your model. So if I go to inspect, and then I go down to interference, and then I select everything, and we try to compute, no interference is detected, which means that this will work in the real world, because you can easily design stuff in CAD that can't exist in the real world because, you know, the parts will just phase through each other. So no interference is detected. That's exactly what we want. We'll move forwards to making our little case. Designing the case itself is very, very simple. Essentially, all I've done is created a sketch that occupies the bounding box of the folded up game board with a offset to make it a sleeve, and then extruded it right way down the model. And then I've given it a little end cap like so. But this is where a little bit of artistic flair comes in. I've created an SVG, which lets me stamp Knucklebones onto the cover. Now, designing stuff like this that's artistic in Fusion, forget it. What I actually designed it in is this, which is Serif Designer 2. It's like Illustrator, but you only buy it once, which is fantastic, and I highly recommend it. To create the funky looking design, I just grabbed a text tool, and then what I did is I wrote down Knucklebones, just running hello here as an example. Then what I did, I went to Layer, Warp Group, Mesh, and Mesh lets you just warp this text however you like. So go through, change it up like so. You can always go back and change it. But before this is ready to be sent to Fusion to stamp it into the model, we need to convert this text into curves. And to do that, you go to Layer, and then Convert to Curves. And now you can't edit the text anymore, but what you actually have is a bunch of curves around each letter like that, where you can see it's just got like a spline around it. Each letter is now in place like that. And then to add just a little bit of flair, I added this little blood drop under the bones. To do stuff like that, you just grab the pen tool and then draw whatever shape you like something like this, for example. Make sure it's got some color to it. So it's got a fill. And then you just move it into this position where you want. And you can see the splines here for the O. I hold down shift, grab this one, and then just do add. This is really important because when we bring the SVG into Fusion, essentially what we're going to have is just the outlines. It's going to look like this, and we need a continuous outline to then extrude this design into the part. Go to File, choose SVG. The default settings are totally fine. Export that. And then in Fusion, you go to Insert, Insert SVG, and it'll bring it in at like a random scale, so you can then just scale it again, move it to wherever you like. Then you get the tedious job of selecting every single outline to then create that extrude. And then last but not least, a few little extra chamfers to make the box look pretty, and then a finger cutout so you can actually get it out when you want to play the game. So we're almost ready to export this to make it ready for printing, but we don't want to print it like this, remember. We actually want to go back to before we folded it to here, and we want to export this as an all-in-one print-in-place model. So you go to Export, Save as Mesh, and we want to export as one file, export that. And then I'm going to scroll forwards and export just my box like that as one model on its own, and then we can go open up your favorite slicer. Alrighty, so let's print this print-in-place board. What I have here is the 3MF of all the separate bodies brought in at once. Now, it's really important that we print this all at once as if it's the same model. It's not identified as separate parts. If I go to arrange like this, then you can see it splits it apart. We have the hinges moved. It's not good. We don't want that. Control Z to undo. So before you do anything, do not move anything here. It's really important to go into objects on the left-hand side and then select everything. Control A will work for you. And then we want to select assemble, which makes this into an assembly. It's now one part, or it's considered one part in the slicer, and it will be treated as such and auto-arranged as well. So it's really important, make sure it's treated as an assembly. It applies to any print-in-place model that you import into Bamboo Slicer. And to print this, you probably want a fairly fine layer height, because those clearances, if you print with a coarse layer height, you're not going to get as nice of a curve or as nice of a edge, and is therefore going to ruin your clearances, and the parts might possibly join together or not have as much free movement as you'd like. So I'm going to choose a default of 0.16 optimal, like so. And let's have a quick look at how it slices these printed place parts. So when you zoom in, you can actually see just how tiny these parts are. And even at 0.16mm layer heights, they do become quite coarse as it gets to those sharp curves. So if we go down to the bottom here, this is where all the magic happens. These first layers are critical, which is why this little area here, for that hinge to form, it's the most important bit. If this fails, then it loses footing and it's going to ruin the print. So as it builds up, you can see I've got a tiny little angle there as it builds up, builds up, builds up. And then from here, as it comes up, it starts to form around where that pin is going to form. And you can see that this blue here is the first bridge of that pin that will create this print-in-place geometry. Comes up and then comes back around like so. And then we get the model joining up like that. This white is where the retractions occur, so that's where the seam will be. You can't not have a seam, and that should be fine. You can see just like that 0.5mm clearance looked giant when we had it in CAD. This has to be strong enough to survive the board being open, closed, and moved many, many times. And, you know, it does that by building up bit by bit, bit by bit, and then we get to the top of the model, and that's it. Now, this will print fine. I've already tested it. But to add a little bit of extra flair, what I'm going to do is actually go back, and then I'm going to enable ironing. Now, ironing is a really interesting thing you can do with your prints. It doesn't change anything except the aesthetics of the print, where it will go over those top surfaces and actually just run the nozzle back and forth, but not print anything. It's essentially smoothing out the previously printed layers using the hot end. So I'm going to go to iron all top surfaces like that. Now you get this funky looking detail on the model. As it's printing, it comes up like that. Then the ironing detail will be this sort of back and forth rubbing of that nozzle to create a smooth result. Ironing works best on large models like this with large flat surface areas. Don't try to do it on organic models. It's really for just flat top surfaces. And this is going to look pretty funky, so let's send this to the printer. I printed both parts on the A1 Mini from Bamboo Lab, and it's an incredibly fast 3D printer. I have a review of it you can check out here. But unfortunately, I did find that little hinges were breaking free during the print, and I did need to use a brim. This isn't such a big deal though, because it actually removed really easily after the print was done. As you can see, you just peel it off by hand, flex it, and then it pops free from the hinges, and the print's pretty much good to go. With that done, we now have to print the case, and the case actually has its own printing requirements as well. So we want this to print with no support material and be as geometrically accurate as possible so that the parts can slide in and out with no problem. And also you want that text to look good. So you don't want to print it like this, although it might be tempting to, because you're like, oh, it's got a lot of good contact on the base of the bed, like that. But not only will this make the text look pretty average, but you've got that huge bridge overhang there. And technically you could have support material to support, you know, this little bit here with the tab that forms. But no, what we want to do actually is print this. We go back to the lay on face on its bum, like that. Orienting the part like this will then result in a print like this, where it's printing up from the bottom up to the top, like so, and it doesn't need support material. Yes, I've actually got the text coming out and in of the model by 0.3 millimeters, and yes, it'll do that over some unsupported areas as it builds up, but it's not nearly enough to cause a problem. It's only a small detail, and this will give us the optimum looking quality of that text because the layer height is 0.16, the nozzle size is 0.4. What's a finer number? The layer height. So you actually get finer looking details on the sides of models when you print at a fine layer height than you could possibly ever do using just the nozzle as a thick, like crayon, essentially drawing in those top surface details. The only thing you might want to consider adding with this model is printing with a brim, because it's only got a very small contact surface area like that. And if you have issues with bed adhesion, well, as it gets taller, it might get knocked off or wobble off or get poor inaccuracies due to vibration. So the only thing you might want to consider is a brim like this, you know, say 5 millimeters or so, where it'll stick it down like that. And when the print's finished, you just peel it away. But I haven't needed to do that. So here I have the game board, and it works. Those hinges are quite loose. Remember the 0.5 millimeter clearance, but no problem at all. It closes perfectly flat and it opens up so you can place it on the table to play your game. So what I have here are all the dice, and the idea is that when you're done with the game, you put them back into So the idea is that when you're done, you put them back into that little dice rolling area, then close up the game like so. Now, because of the way it operates, there is a gap here. I could not close this gap and make it fold on itself. If you have a crazy clever idea of how you might have made that work with this print-in-place design, then let me know. Still, the dice go in there and it's no problem. It holds it perfectly. And this is the case. I printed it in this gorgeous gold polyalchemy elixir PLA, which you can't get anymore, but you can get other shiny PLAs. And the folded board just slides into it like that. And it's nice snug fit. I did add a little bit of clearance. It could have potentially even less clearance. But, you know, you want it to be able to come out when you want to use the game. You don't want it to be completely stuck in there. And it's so satisfying. It's such a small, compact travel size. So when I'm ready, I can just take it out, open the game, and then play Knucklebones in the real world with my friends and family. If you'd like to download and print your own version of Knucklebones, then there's a link in the description below. And I've released the source files as well over on the Makers Muse community if you're interested, which you can join for just a couple of bucks a month, where you can ask your troubleshooting questions. I share behind the scenes details of what I'm working on, and you can talk to other people in the 3D printing community. Don't forget to subscribe so you don't miss any future 3D printing tips, tricks, reviews, and tutorials here on Makers Muse. And if you get a chance, go play Cult of the Lamb. It's a really fun, cute game that doesn't take too long to play, and it's made by an Australian game dev, an indie game dev, which is really, really cool to see, and it's linked in the description as well if you want to go check that out too. Thanks for watching, guys. Bye.